In this chapter, we're going to look at the shading and rendering pipelines in both Maya and in Houdini. In Maya, that's done through the hypershade, and in Houdini, that's done through the matte context, which is a high-level context that sits on top of shops. But we will look at that when we get into Houdini. So here I am in the hypershade, and I'm going to create a standard surface shader. So this is actually a renderer called Arnold, which is also available as a plugin for Houdini. So everything I do here in Maya, we can actually do in Houdini if you were to use Arnold as the renderer in Houdini. What we're more interested in is how the hypershade here works and how the matte context works, and it doesn't matter which renderer you use, the way that we work with the nodes will be the same. So here I've created an AI standard surface, and I'm just going to use the clay preset. I'm going to create another AI standard surface here. Let's just hide that node, and I'm going to rename this one to, let's try copper. And I'll run the copper preset into that one too. What's interesting is that most of these physically based renderers these days use very similar shading models. Both Mantra and Arnold use the metalness and roughness model, and they both can be fine-tuned to remove the noise in the same way by putting in AOVs of the different indirect contributions and then tuning the samples for those specifically. So the way I can work here is with the IPR in the viewport here by pressing play, and we can get quite a fluid way of working, being that we can sort of drag the shaders on. Oh, that zoomed in a little bit, and preview them and see them update immediately. So we can see I'm switching between the clay and the copper here. And we can do other things sort of with the Arnold renderer. We can pull off some of the geometry properties, and what I mean by that is if I just go to texture, I can pop in the curvature, which samples the curvature of the geometry. Now to preview this, I just need to pop in a flat shader. Let's just stick that onto our little piggy head here, so I can see the exactly what this curvature is doing. Let's plug the out color into the flat there. Now what you can see as I'm wiring these nodes together in a very Houdini-like way, the hypershade is fairly easy to use. As you know, it's designed for you to use the networks, and you won't see a lot of that looping that you see in the DAG nodes. So here is the result of the curvature, and we can see that there. In fact, you can see we've got the concave on, so we're seeing the rounded edges. This is like the bits that would get worn of your metal on the outside. I actually want the concave, which are the inner bits here, where dirt and dust might collect. Let me just increase the samples a bit, up the radius and drop the spread a little, and let's just multiply that up a bit to make it a bit more contrasty, so it will become a good mask for us. So the reason I'm using this curvature is because I'm actually going to use it as a mask through the AI, where is it? There it is, the mix shader. So the mix shader will allow us to mix two shaders together. So let me just grab the out color from our copper into shader 1 and our clay into shader 2. If I pop the mix shader on there, we'll see we get a blend of the copper and the clay. And if I set the value to 0, we'll see the copper first, shader 1, and if I set it to 1, we'll see shader 2. So this is what I got my curvature for, so I can take out the, actually let's open that up, just take the red component, we'll plug that into the mix, and now we'll see that we're using the curvature of the geometry to put, basically give us a dirt map, the clay to be the dirt map collecting in the grooves. So we've built a procedural shader, admittedly using Arnold nodes, but we did that within the hypershade in Maya. And this environment allows you to put these nodes together, use nodes that read the geometry properties, and create some more complex layered shaders. So we can pretty much do the same thing in matte in Houdini. So let's pop over there and have a look. So here in Houdini, again we have the same scene with the test geometry sitting in there, and we've set up the lights at this object level context. So the easiest way to apply materials is basically through the material palette. This is not the matte context or similar to the hypershade. This is kind of like the bin section of the hypershade, where we already have some pre-made shaders here, and we can sort of drag and drop them in and apply them directly to the geometry. So I've popped one in here, the principal shader, and as you can see it's very similar to sort of the AI standard shader, being it's got metallicness and roughness. So it should be quite familiar if you were coming here from Maya. Let me pop over to the matte context. So I can either double click on the shader here in the material palette, and that'll take me direct to matte, or in the tree view, which I prefer, we can just click directly on the nodes. So here's my principled shader node. And just like Maya, I want to create an IPR so I can see the live results and work quite fluidly on some look dev. So we can do that. We can switch to render view here, and I can hit render, and then we'll see that our little piggy will kick in a minute, and we'll get our live updates. In the meantime, I'm going to rename this principled shader to clay, just like we did in Maya. And again, if I select the node, we can run up here and use a preset, clay, and we get our clay shader. And again, we can drag and drop that on like we did in Maya. So I'm going to make a copy of that, and let's call this one copper as well. And I'll run the preset for this to be copper. Again, if I drag the copper on there, you can see we can switch between the two. Let me pop the clay on again. In fact, let me make the clay a little bit more red, like Maya's clay. A bit more funky there. So just like Arnold, we can use the geometry properties like curvature. So let me hit tab and type curvature. And I can preview the curvature directly here without plugging it into a shader there. And again, I'm going to use, without plugging it into an extra shader. So again, I can use the curvature in through a mix node. So the mix node that we use in Matte is just layer mix, actually. We're just going to call them layers. So here in the layer, I'm going to put my copper in as layer A and my clay in as layer B. And let's just drag that over the IPR and just see the result of the layer mix. And there we go. So if I bring the alpha down to 0 there, we should see all of our copper, the shader A. So just wait for that to refresh again. There we go, you can see the coppers coming in. Incidentally, if you left click, Houdini will update under your cursor. And if I put it up to 1, we'll see our clay, just the same as Maya's. But if I run the curvature in there, we can see the curvature's kind of inverted. What I really want is collecting in the grooves how I want, but what I want is the colours to be the other way around. So I want this to be white and this to be black. So I can do some simple maths. I could create a constant node, for example. We'll give this a value of 1. And then what I can do is I can subtract this curvature from 1. So if we're taking the white values, the ones, because this is always range between 0 and 1. So if I take the whites away from 1, I'll end up with 0. And if I take the zeros from 1, I'll keep 1. So I look at the result of the subtract. We can see that's inverted. If I plug the result of that into the alpha of the layer mix there. So I have to get in a bit closer. It's a bit fiddly. Let's drag the layer mix on. And then we'll see that that's now kicking in for us. And we're getting our dirt collecting in the grooves, just like we did in Maya. So instantly you can see this matte context is very much like the hypershade. The fact that we can just get the shaders, we can layer them together, and we can have we can feed layer mix into layer mix, and that's all going to work for us. We can do a little bit of maths as we go. We can also do the maths in the hypershade in Maya. So another little thing we can do here is grab some geometry attributes. Let's have a quick look at that. Let me just switch to the scene view here, and I've dived inside the pigs SOP network. So I'm going to create a VOP. VOPs are Houdini's VEX operators. So this is like visual programming with Houdini's VEX language. I'm going to explain this much more in detail in the next chapter. This is very similar to kind of what you can do sort of the new Bifrost board. In fact, the new Bifrost board is very similar to VOPs, but I don't know if you noticed as well that the shops themselves are very similar to VOPs as well, because they are also based on VEX. So let's just pop into there and see what we can do. So the first thing I can do here is I can use this relative bounding box node, and what this does is it gives me a point that's relative. It gives me a relative position in the bounding box of a sampled point. So we'll plug in the position of the current point, and what that means is this is going to cycle through all of the points on the pig's head, and it's going to say where is this point relative to the overall bounding box. And what I mean by that is if it was halfway in the bounding box, we would get a 0.5. If it was at the top, we'd get a 1, and if it's the bottom, we'd get a 0. I'm going to plug in op input 1, which is this actual geometry, and this returns a vector in the x, y, and z 0 to 1 depending on where the point is. If we use a vector to float though, we can extract the individual components, and it's the y bounding box, the height, that I want. Since that's now a normalized value between 0 and 1, I can feed that into a ramp. Let's make that a spline ramp. And just to show you what the ramp's doing, let's just plug that into the color, the vertex color, and we can see that we're coloring, well, we're not coloring the pig, it's all black. That's because we're using this ramp here to color it. So if I just make a little step here that's white, you'll see that I'm coloring the pig from the base here to the tip using that normalized value based on the bounding box, and we can create an interesting mask based on the height here, not just the curvature. The reason I'm doing this is I don't want to feed that into color like this. Let's delete that connection. What I'm going to do is use a bind export node to actually send this data out and create an actual geometry attribute for it. So let's call this mix, because that's what Houdini does best, is deal with the attributes. If I look in the spreadsheet now, we can see we've created a new point geometry attribute called mix, and the values vary between 1 and 0 based upon our ramp here. Now we can bring that directly into the mat context here. So let's have a quick look at that. Let me hit render. So we get the IPR coming in again. So we can add a bind node. What a bind node does, it does the opposite of the bind export. It brings that data in. So let's call this mix. Make sure it's the same data type. And that will now bring it, if there's a mix attribute on the geometry, that will bring it into this shader. So there we are with the curvature, but if I plug my mix in here into the alpha, we'll see that we should be now blending between those materials based on the attribute that I made using the ramp. Because remember, all Houdini does is worry about the attributes on the points, and if they're there, we can access them and use them elsewhere. And now I can see my ramp is directly affecting the blend between these two materials, and I can update that and see that affecting on the itself in real time in the IPR there. Now interestingly, we can do a similar thing in Arnold and therefore in Maya. So let's have a quick look at that. Let's just pop over to Maya again. Here we are. And what I'm going to do is just stop this IPR, and I'm going to create some geometry attributes on here. Now to preview this, I'm just going to pop a Lambert in there, because what I want to do is paint some vertex colors, and they won't show up with the Arnold shader on there. Let me just get the tool palette up so I can change the color of this. So there we go. Let me flood the pig all in black here, and let's turn off the wireframe there. And what I'm going to do is set this to white and paint some white on the mask. So what I've done is I've created a color set where I've painted these vertex colors, and that's not really an arbitrary attribute. It's a color attribute there. And what we can do is if we go to the color set editor, we'll see the name of this is color set 1. That's important to remember that, because what we're going to do is we're going to bring in that attribute into our mix shader. Let me apply the mix shader. In fact, let me apply the flat shader and hit the IPR. So what I want to do is bring in that color set 1, and we can do that by clicking on user data and do AI user data color. So this will bring in AI user data of the right data format. So we just need to give it the same name here, which is color set 1, and this will bring in our vertex colors. Let me plug that into the flat shader to see the result, and we'll see there's nothing there yet. That's because we need to tell Arnold to pass the data through into the geometry. If I select the geometry here, let me just delete the history on it to make sure there's only one shape node, and there it is. And we can come into the Arnold tab of the shape node here and turn on export vertex colors. Let me just stop the render and re-render again. That's not kicking in. Let me just reapply the shader. That's still not working. Let me just export vertex colors. There we go. So if I hit render again, sometimes it fails to refresh itself. So there we can see the vertex colors are coming through based on what I painted there. So if I just paint a little bit more, so just to show you that with the Arnold shader on here we won't actually see the white. So let me just paint a little bit there. If I press play, alright, have I got the right color in there? It doesn't seem to want to let me paint it with the Arnold shader on there. Okay, let's drag the Lambert on. Oh, now it's doing it. Interesting. Let me stick the shader back on. Oh, the flat shader, it's not updating properly. Okay, sometimes it Maya does that, doesn't catch up on itself. Let me just try and do Where is it? Update full scene. Yep, there we go, that works. Sometimes you'd have to tell it to update full scene, which gets it to catch up with itself. So there you can see as I'm painting the vertex colors, the data's coming through into our shader. So I can apply the mix shader here, and then if I use the, say, the red component of this user data as our mix, we'll see now that I'm mixing based upon what I painted. It's not so easy in Maya to actually grab things like the bounding box and other stuff like Houdini. That's where the interesting stuff comes in SOPs. You've got all these other nodes to calculate stuff more easily to the geometry. I mean, you can do the same in Maya, but you need to start getting very much into the scripting. So let's have a look at now sort of the rendering and render layers and takes and render globals between the two different softwares.